Okay, we're going to go over your test here really quick. In the first question, where we're working with the flagpole and the building, so I have a diagram here of the building along with its shadow. It would make a right triangle with the rays of the sun. Same with the flagpole, the height of the flagpole, the shadow, and then the rays of the sun. So we're looking for the height of the building. We're given that the shadow is 26 meters, the height of the flagpole is 25 meters, and then the length of the shadow of the flagpole is 10 meters. So what I did was set up ratios because we have two similar triangles. So whenever we're working with two triangles, the easiest thing to do is set up common ratios. So I have height of the building divided by the height of the flagpole. So the ratio of those two sides should be equal to the height, or sorry, the shadow of the building divided by the shadow of the flagpole. Quickest way to do this is just to set up two equivalent ratios like this, cross multiply the 25 over. So get rid of the 25 here by multiplying. We have 26 times 25 divided by 10, and you get 65. Again, as with all math questions, there are multiple ways of doing things. Just because you did it a different way and you didn't, you may not have got all the marks simply because, and I was fairly generous on this test, but while there's multiple ways of doing things, there's not always, they don't always reflect what we're learning, and they don't always reflect the most efficient way. If you go about a way that takes 10 minutes and you, where there's a more effective method that you know of that takes only 1 minute, choosing the wrong method, then you've wasted 9 minutes, which could potentially be 9 more problems that you've solved, whether it be explicitly in terms of math or in terms of anything else in life. So choosing the most effective method is also very important. And that kind of idea comes up in number 2 here. A set of stairs has a slope of 3 over 5, so Lot went to start working with Pythagorean's theorem and finding the hypotenuse as they drew this on a grid. And it was a lot of work when really all the work required was to set up a tan ratio with the opposite side being 3 and the adjacent side being 5. There's my stairs, so there's my two sides in terms of the ratio. And remember, regardless of the size of the triangle, the ratio is always the same, so that angle will be consistent. So I just set up a quick 3 over 5 ratio, and then there's my tan 0.6, and then tan equals 31 when I do the second function tan, or look that up in the table. And again, if you feel more comfortable with that, then put your 4 decimal places there. Again, I usually don't put them there if there's zeros because they're implied. So the first 2 questions there were 3 marks. The next question, again, working with the sine, cosine, tan ratios. In this case here, though, we're looking for a side. So this is the time where you're going to calculate the cosine of the 55. And again, cosine because I have the adjacent side and hypotenuse side here. I'm given the hypotenuse. I'm looking for the adjacent, the distance between the two people. So cos 55 equals whatever over 45. And again, I'm using just a question mark here because you don't have to use an X all the time. You can use whatever you want. So just to reflect that, doesn't matter what you use there, X, P, W, a happy face, I think I seen at one point. Anyways, took the cosine of 55, which was 0.5736, and then just multiplied that by 45 to get the result of 25.8 meters. 3 marks. Next question, we're working with some similar triangle ideas again, and what we're given is Jacob's scale drawing of his triangular garden. So in this case, we know that the hypotenuse of the actual garden is 12.5 meters, and we want to find the scale factor. So that means we're going to need to know the hypotenuse of this triangle, and then we can compare them. So I found the hypotenuse using Pythagorean's theorem. I also took the 12.5 meters of the real garden and converted it to centimeters so that we had similar units. And this is a mistake that a lot made. You just compared 12.5 to 25. But note those are completely different units and so significantly different answers. And then I just compared myself. I compared the drawing to the actual. So 25 over 1250 which simplifies down to 1 to 50. So the comparison is 1 to 50, or the scale factor would be 50, because you could actually do actual over drawing. I accepted both results. That one there is for 4 marks, the additional mark coming from the fact that you had to recognize the transfer of units. Number 5, we're looking at the plane flying. So we got a plane flying parallel to the ground. So there's our horizon line, and we're looking for an angle of depression. It is at an altitude of 1,500, and it is 4,000 meters away from the runway, where it's going to end up touching the ground in the future. So here's our setup. You either have that this angle here, you could either draw it this way, where this is our angle of depression, and then because of the 2 parallel lines and the Z pattern in the parallel lines, the angle of elevation from this point here would be the same as the angle of depression from this point here. This is always going to be the case. The angle of elevation from the one side is going to be the same as the angle of depression from the other side. Notice angle of depression is not inside the triangle. It is from the horizontal and goes down. So it's outside the triangle. And that's why this triangle works. Or more effectively, you can use this triangle here. You still have the plane 4,000 meters away from this point. It's still at a height of 1,500 meters, but there's your angle of depression inside the triangle. And so both of these triangles are the exact same triangle. It's just spun around. Both diagrams would work in this case. Either case, you have the tan of theta is the opposite, 1,500, over the adjacent, 4,000, and then you work that out. If you were using the table, you probably would have got 20 or 21, and then the calculator method, where you got to the nearest tenth of a degree, is 20.6. 3 marks for that part. Number 5b, 2 marks. All you need to do here is just use Pythagorean's theorem. You have your triangle with one side being the altitude of 1,500, and then the distance to the landing strip being 4,000, and then how far did the plane fly would have been coming down along here. This is where the plane is flying, along the hypotenuse. You just use Pythagorean's theorem to solve that. 4,272. Some people use sine cos, the sine costan ratios idea here. Well, that is going to work. If these are rounded numbers, then you're going to get a different answer here. And again, you should always be looking to use the values that are given first before you use values that you calculated in case of rounding or calculation errors. So picking the Pythagorean theorem here is the most effective method. Well, I did accept people that use the other method. The sensible method would be to make sure we got everything right by using known values rather than calculated values whenever possible. And again, that's not something I'm discussing now as a brand new topic, but something we discussed on the or during the unit. Tree problem, we're looking at the height of the rock ledge. So we have a triangle in the first part here. There's my right triangle. I have a distance of 100 meters here, and then again using the idea that this angle of depression right here is going to be the same as this angle here of 10, you can use the tangent ratio to calculate this. Subsequently, if we know this is 10, some people may have recognized that this is 80 degrees and use the 80 degrees and then you would have just had the tan ratio flipped around, and you had 100, tan 80 equals 100 over x to solve that as well. But this would be the most effective method to do such. And I re-illustrated those in the diagrams here with those 10s. In the second case, we have this right triangle here with the 25. And again, this distance here is 100 because it's going to match this distance here. So we just use tan 25. And solve that for 46.6, which we then add to the 17.6 from the previous answer and get 64.2. 3 marks for A, 3 marks for B. Number 7, a little more complex. I did take away a mark if you put that this is X and this is Y and then said x equals 6.3 and y equals 3.6. I took away a mark because you did not label the measures on the triangle. X and y are not the measures. They are variables, and the question explicitly asked you to label the measures. So you didn't put the measurements on there, and you lost a mark. So that was one mark. It was to actually label everything. So you should have 25, 25, 15, 13.6. And if you wanted the longer decimal, you could use that. And then the 6.3. Angle A here, we're given angle B, we're given the hypotenuse. Angle A is just 180 minus 90 minus 25 for the 65 degrees. And then to find the remaining two sides, again, selecting to use the given values, 25 and 15, 25 degrees and 15 would be most ideal because you're less likely to have a chance of error with either this angle or one of the calculations along the way. I use 25 and 15, so sine opposite over hypotenuse for AC, which was 6.3 in the end, and then cosine of 25 because we had adjacent and hypotenuse for BC, which was 13.6. 6 marks again there. And then the final question worth 7 marks, multi-step. Yes, it is difficult to read, and some of you misinterpreted what you read. However, that is being able to interpret math is important. The concept here, first off, that it was 2.5 times as far from this point to this point. So this whole W here was 2.5 times as far. This from here to here was not 2.5 times as far. It was 2.5 times as far from the pole. So that there isn't a big there's lots of words there, but that's not a complex statement when you look at the specifics there, that the second is attached 2.5 times as far from the pole. So that means 2.5 times as far from the pole, this whole distance. So I calculated that in my step 3, 2.5 times 9. That gave me my whole W side here. And then I just used alpha, beta, and gamma for my 3 sides. So I called this piece here alpha, and then called this beta. You could use X, Y, W, anything you want. These are just I just stuck with the Greek letters. And then I considered this whole side here as gamma. So alpha, beta, and then gamma was the sum of A and B. So found alpha by just doing 180 minus 65 minus the right angle. So that was 25 degrees in here. And then I found the height of the pole, and I did that using tan 65, where I had h over 9, and solved that for 19.3. And again, I found the W, so 1 mark, 2 marks, 1 mark. Then I needed to find the entirety of this angle, so angle gamma. So what is A plus B? That's going to be my angle gamma. So that was the W over the H, because I had the tan of that, opposite over adjacent, and then I filled those in. So 22.5 over 19.3. The common mistake here was just people just did this upside down and did 19.3 over 22.5. So make sure that is done in the right order. It is this angle you're looking for here to find this whole angle, so then we can find this little piece. So that was 49.4. And then the final piece for the final mark was to subtract alpha from gamma. And that was because this whole angle is not what you're looking for. You were looking for the angle formed between the 2 cables. So the angle beta is the angle in between the 2 cables, just from this cable to that cable, not from the pole to the cable. And thus I just subtracted those, and you get 24.4. Again, you need to make sure that you are picking effective methods when you're solving these. Yes, there's a whole bunch of different ways a lot of times to solve things. However, doing Pythagorean's theorem to find the hypotenuse on a question like number 2, and then using a cosine law to solve for the angle is going to give you the correct answer. However, Pythagorean's theorem and the cosine law is going to be 2 full equations versus 1, so you're doing something that is much less effective. And understanding sine, cos, and tan ratios, the fact that you had a triangle set up like this, you should right away recognize that the tangent ratio is applicable in this situation.